Hello friends, welcome to engineering tutorial. So today we are going to start a new subject, okay. So it will be mechanics, okay. So like we do in all the previous subjects that we start, we first go through the basic introductory concepts and then we progress forward. So this first video, it will be related to some basic concepts related to the subject of mechanics. So first, what is the basic definition, okay, of this subject? So basically it is a branch of physics which deals with the study of forces, the motion and rest, these three concepts, okay, and the interrelationship between them. So basically it tries to answer some basic fundamental questions, that is why objects they remain at rest when they are undisturbed, and when they are given some force, why they continue moving, and for how long they move, they keep that movement, they keep that motion until they come to rest. So if we want to put or try to understand mechanics in simple terms, in simple keywords, it involves, first of all, the most important thing, an object, yes, that is involved. Then the concept of rest, okay, when an object which is undisturbed, it remains stationary, that is the basic state of rest of the object. Then the movement of the object, that is motion, and it is basically a kind of cause and effect relationship, okay, this. So here this effect which is produced is these, that is rest and motion. And what causes the object to remain at rest and what causes it to remain in movement or motion, that is what we are going to find out. So it will involve various principles related to it, various mathematical equations, various kind of derivations will come into play, different surroundings, different situations, so all that will come into play. So here other things will come into play, such as the concept of point objects, which we will discuss in this video, point objects. Then there will be the concept of magnitude and direction. Why? Because we are going to measure it. If we cannot put it in terms of a numerical value and with a proper direction, then it has no meaning, okay. Then in order to measure the magnitude and direction, we need a measurement system, okay. So here we will be using a coordinate system, and with respect to what we are measuring, with respect to the base value, with respect to what we are measuring all these things, okay. What is the reference? That brings frame of reference into play. So in all the topics related to mechanics, these things will come into play in one way or the another, either directly or indirectly. And if you understand it closely, all the topics of mechanics, it involves rest and motion of the objects, and it is basically cause and effect. The effect is either the object will be at rest or it will be in motion. If it is at rest, why it is at rest? If it is in motion, why is in motion? That we are going to answer, and that answer, that solution, is what this subject is all about. It can be in the form of basic principles, theorems, it can be in the form of mathematical equations, derivations, whatever. Okay, this is the basic highlight of the subject of mechanics. Okay, now in order to simplify our study, we will categorize it, divide it into three categories. Okay, the study of mechanics is divided into three parts: statics, kinematics, dynamics. Statics is basically the study of the objects which are at rest, no movement, stationary. Okay, kinematics is related to the branch, the mechanics branch, which deals with movement, objects in motion. Okay, and dynamics is the cause, basically the study of cause of rest and motion. Okay, we try to answer what causes objects to be in motion, and finally why they come to rest, like that. Okay, but statics and dynamics, they do not bring the cause into play. They are only concerned with the effects. Like I said here, cause and effect, statics and kinematics, they are concerned only with the effect of rest and motion. Statics is related to objects at rest, kinematics is related to objects in motion, that is the effect, but dynamics studies the cause of rest and motion. Okay, so why these subjects are important? Study of statics is important basically from the point of view of civil engineering, architectural engineering also, which is helpful in the design of various structures such as buildings, bridges and other structures. Kinematics is important because there is a huge scope, okay, of statics, kinematics, dynamics, which cannot be confined in this thing. There is movement everywhere. Okay, planets are moving around the sun, moon is moving around earth, then whatever vehicles they're moving, we human beings, we move from one place to the other. So there is movement everywhere, so you have to study it. So okay, so here another interesting thing, that kinematics is derived from the Greek word kinema, meaning motion. Okay, similarly the study of the cause of motion is also very important, because once we understand the cause, we can understand the effect in a much detailed way, and then we can manipulate the cause and effect relationship to produce effect according to our choice. Okay, so that's why the study of dynamics is also important. So here the word dynamics is derived from the Greek word dynamis, which means power. So here is the basic breaking down of the study of mechanics in three different parts. Then there are some basic terms which are used. Like I said, it will come into play in the study of mechanics. They are, first is object. Of course there will be object, there will be which is the focus of our study. Then we have is a frame of reference, the reference point, like I said, with respect to which we are measuring rest and motion. Then there is the effect of rest and motion. Okay, this is the effect, rest and motion. So first and most important is the object, which is the focus of our study. So here, for simpler analysis, we consider the object as a point object or particle. Okay, but can you consider a human being moving on the road, which is the object of the study, as a particle? Can you consider a large aeroplane which is flying as a particle? Can you consider a car or a bus or a huge building as a point? So it depends. If the size of the particle is small as compared to the, you know, the distance it is covering, or the size of the location with respect to which we are measuring it, then it can be considered as a particle. So let me try to give you some examples through which we can understand it. Let us say we are trying to let's say measure the or study the movement of a car or a bus which is traveling on a road, and it covers a distance of, let's say, 200 kilometer or 100 kilometer, whatever, even 10 kilometer. So here the length and breadth of the car is very small as compared to the distance which it is covering. Okay, so in this case we can consider this car as a point object moving with a certain velocity, okay, with a certain value of acceleration, covering a certain distance. Okay, here we can represent it as a particle because the distance which it is covering is very high as compared to the size of the car. Similarly, if we consider let's say a satellite, the movement of a satellite around Earth's orbit. So here, okay, if we are considering the movement of a satellite moving around Earth's orbit, so here the circumference of the orbit, the distance which it is covering, is very high as compared to the size of the satellite. So here it can be considered as a point object. Okay, and another simple example, let's say we consider a simple pendulum arrangement. So here the size of the bob is small, not very small, but it is small as compared to the length of the string to which it is attached. So here the bob can be considered as a point object. So it all depends upon that. Okay, a person walking on the road covering a certain distance, the size of that human being or that person is very small as compared to the distance which it is covering. Okay, so in that case that person will be considered as a point object. Okay, an aeroplane, okay, which is flying in air covering a huge distance, thousands of kilometers, the size of the aeroplane is very small as compared to the distance which it is covering, so it will be considered as a point object. So this is the concept of point object or particle. So here the basic definition of a point object or particle is that it is an isolated point mass having no size, which means as compared to what we are measuring, you know, the surroundings, everything taken into play, like I explained these things here, and it is incapable of rotation, rotating about its own axis. Okay, so this is the concept of point object or particle. Then is location. So here if we want to measure, you know, the rest, motion, everything, we have to put it in numerical values. Okay, so here, like I said, the concept of magnitude, direction, all comes into play. So let me give you an example. Suppose you went to visit your friend who is living in another city, and you've never been to that city before or to that state before, and you arrived at the bus station or railway station or airport, and then you asked for locations to your friend's house, and he said, when you called for when you called your friend, he gave you things like this, statements like this, that is, walk 10 kilometers, then walk 5 kilometers, then walk 3 kilometers, then walk 2 kilometers, like that. He gives you directions, he gives you things like this. You'll say, what the hell is this? What are you giving me? And in another case, he gives you things like, okay, first move left, then move right, then walk straight, like this. Only these things. Okay, this is the first case where he tells you walk 10 kilometers, 5 kilometers, 3 kilometers, 2 kilometers, like that. And in the second case, he gives you things like these: move left, right, straight. So in these two cases, in the first case there is something missing, in the second case also there is something missing. In the first case we have the magnitude, okay, we have magnitude, but we lack direction, okay, we lack direction. Here we have direction, but we don't have magnitude. But if third time the friend calls and he gives direction like, from the railway station or the bus station or that location, you move to the left, walk 10 kilometers or take a cab or something, go 10 kilometers, then you will find a traffic square, let's say, and from that you move right, you take the right side and go 5 kilometers, then there will be a coffee shop. From there you take straight 3 kilometers, and then let's say he says take the right side, the right direction, and walk 2 kilometers, then you will arrive at my house. Okay, starting from the station, then towards the traffic square, then the coffee shop, then finally at house. So here in this statement we have direction, we have magnitude, and we also have another important thing, which is reference points. These, the station or the airport, then the traffic square, then the coffee shop, and then finally house. These are very important when we are trying to understand the concept of rest and motion. So if any of these three things is missing, then it is very hard to understand. Okay, this is the proper way of describing or giving directions to someone, some unknown person who is new to your place, to give them your location. So this is what frame of reference does, frame of reference and location. So here, in order to locate an object in space, what we do is we use a three-dimensional coordinate system. Okay, x, y, and z, x, y, and z axis. Origin is the reference point, the starting point, everything is measured with respect to this starting point. Okay, so here if we want to locate a point in space, let's say we have a coordinate point, let's say 2, 3, 4. So it means if we try to put it in the same way, the final location is this 2, 3, 4, this point. So here first the object will start from O, origin, which is the reference. It will walk 2 units on the x-axis here, 2. Then it will move 3 units in the direction of the y-axis here, 1, 2, 3. Okay. Then it will move 4 units in parallel to the z axis. Okay, so like this, 1, 2, 3, 4. This is the point. Okay, P. So it is very difficult to give you an idea of three-dimensional thing in a 2D visual setup, but this is the point. Okay, any way it can be done. Suppose first he starts in the direction of the z axis. He walks 4 units in the direction of the z axis first, then 3 units in the direction of the y axis, then 2 units in the direction of x axis. He will arrive at the same point P, that is 2, 3, 4. So no matter in which direction you move, you will arrive at the same point. So here the concept of reference point, which is the origin, magnitude, that is 2 units, 3 units, 4 units come into play, which is the magnitude, and then we have x, y and z direction. That is also very important. So here we use the Cartesian coordinate system to specify the location of an object, the point object in space. Okay, so if any of the coordinate points along any direction x, y, z changes, we say that the object is in motion. If none of the coordinate points x, y and z, they do not change, then we say that the object is at rest. Okay, then we have what is called as the frame of reference. Again, let me try to make you understand. Again, it is the same thing, reference point, but okay. Now here, let's say when you use postal addresses, there is something called as a landmark. It will be given. Give the nearest landmark. It can be anything, an important historical structure or monument, or it can be a famous shop, or it can be the nearest railway station, police station, anything. It can be the airport or the nearest school, college, anything. So the basic purpose is to, like I said, along with magnitude and direction, it helps in quickly arriving at the desired location. Similarly, when we are measuring rest and motion, here another thing comes into play. Let us say we have, okay, this is the ground, and we have a, let's say, a stone, okay, a rock which is placed, a huge rock which is placed on the ground. Now here this rock is at rest. If a person looks at the rock, he will say that this rock is at rest. Okay, it is at rest. And in another case, we have a rock which is rolling down on the ground. In this case, it is in motion. Okay. So here, this rock is at rest with respect to the ground. Okay, this ground, with respect to ground or earth, we can say. It is at rest with respect to ground, because when the person who is located on earth, he or she is stationary, fixed at that point, he sees the rock at rest because it is not moving. Both of them are on earth, the same reference point, the same location. Similarly, here also, the person who is stationary, he sees the rock which is rolling down. In that case, the movement of the rock is with respect to ground, with respect to earth, where both the person and the rock, they are located. Here it is in motion. But if someone, let's say, is looking from the outer space, okay, this looking from the outer space and has a very powerful, telescope, then in that case, in this first case, okay, this one, in this first case, he looks at this rock which is located on Earth. In that case, he will see both this person and this rock as moving in motion, because Earth is moving around the sun and is also rotating about its own axis. Here the frame of reference has changed. Here the person is located in outer space, is in a spaceship or whatever, some alien, he or she is watching this. Then he will say that this rock and this person who are located on Earth, they are in movement, okay, they are moving, they are in motion because Earth is moving. So when we change the frame of reference, then everything changes. The concept of rest and motion, everything changes. But for simplicity, we will not bring the outer space into play. Every measurement which is done here, it is done with respect to Earth, okay, with respect to Earth, where Earth is the frame of reference. We are not interested in outer space, okay. For mechanics, we will consider Earth as the frame of reference. Every measurement is done with respect to it, with respect to Earth or ground, this, okay. So another interesting thing, suppose on the ground also, on the ground, a person is running, and also we have another person which is running. In that case, the concept of rest and motion, suppose they are running at the same speed, both of them are running in the same speed in the same direction, then it will appear as if both of them are at rest, both of them are at rest, because they are moving in the same direction in the same speed. So it will appear, it will create an illusion that they are both at rest, but actually they are moving. So here the concept, there is another concept, I think it will be a bit too early to bring this term into play, but we'll discuss it in detail. The concept of relative velocity will come into play, which we'll discuss in detail. It's a very interesting concept. So just okay, so when both the reference point and the object which is under study, they are in motion with different velocity or same velocity, also the concept of rest and motion, it becomes interesting. Okay, so these are the things. So we have discussed frame of reference, location of objects in space, then concept of point object, which are very important when it comes to understanding the concept of rest and motion. So basically we'll discuss rest and motion in detail in the next video, but in simple words, what is rest, what is motion? So here, if a body does not point object, whatever, it does not change its position with respect to its surrounding and time. Surrounding means ground here, Earth as the frame of reference, then it is at rest. Now if a body changes its position in any direction with respect to its surroundings, that is the frame of reference Earth, and time, with as time passes, then it is said to be in motion for that particular interval of time for which it is moving. So basically, frame of reference is a combination of a timer or a watch which keeps track of time and a coordinate system, okay, the Cartesian coordinate system, which helps us to locate an object in space. Okay, so here time comes into play, reference point comes into play, magnitude comes into play, direction comes into play, and we need all these parameters to understand rest and motion. Okay, so this is for this introductory video. So we'll be discussing more things related to rest and motion in the next video. Okay.